Hello everyone, I'm teacher Yusen and today I'm back again with our RMO preparation videos. And today the question that we are tackling is 2022 RMO round 1 question 7. So without further ado, let's jump straight into our question for today. The question says n is equals to 2022 plus 2022 over 1 plus 2 plus 2022 over 1 plus 2 plus 3, so and so on, all the way until 2022 over 1 plus 2 plus 3, all the way until 2021. Now the question says we want to find the sum of the digits of n. Let us think for a moment. Is it available for us to calculate out what is the value of n directly? Hmm, Most likely, no, right? We are not able to calculate out the question directly. But normally, when we meet this type of question, what is it that we can do to try to solve the question? The answer is very simple. We just try to see if there is a pattern, right? And if we take a look at this question carefully, there seems to be a pattern in it. And well, we can notice that in the numerator, what is happening? All of them are 2022. They're all the same. What about for the denominator? Oh, this seems to follow a pattern, right? So with that being said, what is this pattern that we notice for the denominator? Hmm. For those of you who have been following my videos, you realize that this is just known as a arithmetic sequence. And well, all of their denominator is in the form of an arithmetic sequence. 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, and so on. So now we know that there's an arithmetic sequence. So what do we want to do? Well, we can think of a way to represent the arithmetic sequence into something simpler for us to calculate, right? So what can we use to represent all of them? There is also a special thing, also known as a general term. So what is a general term? It is just a term that can be used to represent all of the terms in the sequence. Oh, then, well, talking about the general term, how do we exactly find the general term? That leads us to think about this question. Since all of them are in the form of an arithmetic sequence, let's say if I keep on going on all the way until the nth term, well, what will it look like? Starting from the starting from the numerator, we know that it must be 2022, right? What about for the denominator? Let's think. Oh, the first one, 2022 over 1. Second one, 2022 over 1 plus 2, and so on, right? So if I reach the nth number at the end, what should be the denominator? Everyone, take a moment and think about it. I believe all of you are able to know that the last one will be 1 plus 2 plus 3 all the way until n. So with that being said, can I simplify this general term then? The answer is yes, right? For an arithmetic sequence, how do I calculate it? For those of you who have followed my last few videos, you will know that the sum of an arithmetic sequence is just the first plus the last multiplied by the number of terms divided by 2. Oh, and about this, if we do it for this question, what do we get? Oh, it seems very simple, right? The sum is just n times n plus 1 over 2. And I think a lot of us would have learned about this before already. So now we have our general term over here. What can we do about this general term? So now we know that, the sum is just n times n plus 1 over 2. But now we think, is this actually our general term? No, because there is still a numerator on top, right? So to get our general term, we'll write it as 2022 over this entire n times n plus 1 over 2. And with that, we simplify it. And what do we get? We get that, oh, it's just 4044 over n times n plus 1. And now, since we have the general term, well, I think we all know what can be done next. We can start putting it in terms of this general term for all of them. And if we represent all of it, what do we get? For the first term, it will just be 4044 over 1 times 1 plus 1, which is 1 times 2, and so on for the rest of them. Oh, once I have this, what do we do now? Since I have this equation, we notice that all of them have the exact same numerator. So since all of them have the same numerator, what can we do about it? Well, we can take out the numerator and put it in front. Oh, now what do we notice about this part within the brackets? This part within the brackets seems that it's all in a sequence. 1 over 1 times 2, 1 over 2 times 3, and so on. And this we have learned before. It is just our fraction decomposition. What can we do about it? We can break it into the differences of fractions as such. And everybody, let's take a look at this picture now. What do we see in this equation? Oh, minus 1 over 2 plus 1 over 2, minus 1 over 3 plus 1 over 3, so and so on. They all can be cancelled out. So what will be left? Everything in the middle will be cancelled out. What's left is just the first term and the last one. And that gives us this. 4044 times 1 minus 1 over 2022. Well, if we calculate it out, we should get 4044 minus 2, which gives us 4042. But don't forget, everybody, this is not the end. The question wants us to find the sum of the digits in case you have forgotten. So what is the sum of the digits? 4 plus 0 plus 4 plus 2. That is just 10. And we have solved this difficult question. So now, what have we learned from this question then? Well, the first thing, of course, what do we need to do when we're dealing with this question? We try to find what is the nth term, right? If there's many terms with a pattern. Well, we find the general term. And once we have found the general term, what do we do next? Oh, we realize that we represent all of the terms in terms of the general term. Be it the first one, the middle one, or the last one, we all change them into the general term. And now, what about the last thing? Well, for this question, what we did was fraction decomposition to simplify all of it. But don't forget, well, there's also other types of decomposition, just like whole number decomposition. So with that, that is the end of our question. But don't forget, that's also our practice question below. So everyone, do remember to try out this question, alright? So with that being said, that is the end of my session today. And do remember to hit the like button and subscribe to our channel below. Thank you and bye-bye.